All right, continuing our list of important words to know, we had real numbers, natural numbers, integers, rational numbers, irrational numbers, and in the last lesson we did variables and coefficients. Somehow I feel like I spelled that wrong, but don't judge. Alright, so that's what we have so far for our list of important words to know. In this lesson we are covering terms, like terms, and expressions. Alright, so a term, according to your textbook, is the most important, one of the most important words to know in algebra because it gets used a lot. And a term is a very general word that stands for any number, any combination of numbers, any set of numbers and variables. All of those are terms. So the number 8 is a term. This term gives us the knowledge that we have a value of 8 whatevers. Another term would be 8y. We, in this case, don't know exactly what the final number is, but we do know that we have 8 of object y. And if object y was hours worked, we have 8 hours worked. If object y was pencils, then we have 8 pencils, that sort of thing. We could also do a fancier term that's like 8yz, which would be pretty fancy. In this case, we have 2 unknown variables in our term, but it's still a term. We could also do things like if you have something in parentheses. Let's say we had 2 8yz, like that, that's still a term. Anything in parentheses that's right next to something else, so we could have 8yz minus 5, still a term. The only time it changes from being a term to not a term is when we have 2 terms that are in a relationship with each other. I'll give you an example. Let's say that we have our first term is 8y, because that's nice and simple, but then we add 8y to 10z. In this case, what we have now is an expression. And this expression is what we're trying to figure out. It's called an algebraic expression, and these 2 terms are in a relationship. We have term 1 that's being added to term 2 as part of our expression. And then finding the answer to the expression would be the goal of our algebraic problem. So those are the important, I just want to point out very prominently that these are all terms. But the moment that we have them in a relationship, so even if the relationship is, let's say it's a subtraction relationship would work, so we could do 8y minus 13b, that's an expression. And the reason it's an expression is because these 2 terms are separate and distinct from one another. If you had something like, sorry, I need my, there we go. So let's say we had 8 times 2. Oh, sorry, that gets confusing. This is a times sign. 8 times 2y. And then we do plus 5. This would be an expression, but this expression only has 2 terms. The 2 terms are, this is term 1, x times 2y, and then plus 5. And anything that's multiplied or divided by itself like this is still part of a term because multiplication and division affect the quality of that number itself. We could write this problem, this term, as 16y. We'll cover this more in the future, but 16y, just as easy as we could do 8 times 2y. In fact, this would be the simpler, more preferred version of how to write this. So it's still just a term. And then when we add it to 5, which doesn't add very easily, because 5 doesn't have y next to it, we'll get into that, that's when it becomes an expression. So anything that's added and subtracted, terms that are added and subtracted, are part of an expression, but anything that's multiplied would still just be a term within itself. Hopefully I didn't make that too confusing. If I did, reach out with questions. But the other important thing that we can do once we have terms is we can add like terms. So a like term is a fancy word, like term. fancy word that means anything that has, in the textbook, they say anything that has the same last name is a way to remember it. And then like terms can be added and subtracted from each other or to each other pretty easily. So when I say the same last name, I mean something like if we have 7y plus 13y. Now we know that we can pretty easily add something like 7 plus 13 together. That's just a standard addition problem. But when we get the variables on, if they're not exactly alike, then we can't add them together, because that would be like trying to add a combination of apples and cucumbers to something that just has apples in it. It doesn't work very well. That would be like trying to say that if your family is the Smiths and somebody else's family is the Jones, you just add yourselves together and you're all one big family, but really you know you're not, because half of you are the Smiths and half of you are the Jones. It just doesn't work. So you need to have the same last name in order for it to be a like term. But as soon as you do have a like term, just a y and a y, we can add that together as easily as any addition problem, and it just becomes 20y. That's our answer. But if we had something like 6xy plus 2y, well, those terms are not alike. This would be the Smiths, and this is the Joneses, and you can't just add those together and get one big happy family. So these are not like terms. Let's do one more practice with a like term, maybe two more. Let's do 3ab minus 2x plus 7ab. What does that equal? Well, in this case we have some like terms. A and B, look, they match up. They have the same last name, but this one is not a like term. So in this case, our answer to this problem would be a little bit long and complicated, but not too bad. We can do 3ab plus 7ab, which equals 10ab. And then, because we can't add the x to it, he's not part of the family, we'll just take 2x off. So we've simplified our expression. We made it a little easier. Instead of having 1, 2, 3 terms, we now only have 2 terms, which is nicer. We've added any of the like terms that we could, and this is our new expression. Alright, hopefully that makes sense. Once again, reach out if you have any questions, and I'll see you in the next video.